Permanent mold casting uses a metal mold constructed of two sections designed for easy, precious opening and closing. The mold used for casting alloy melting point alloys are commonly made of steel or cast iron, while the mold used for the casting of the steel must be made of refractory materials due to the very high pouring temperatures. The advantages of permanent mold casting are the good dimensional control and surface finishing, and also the rapid solidification caused by the metal mold results in a finer grain structure, so the casting are going to be stronger with a better mechanical properties. While the limitations are, generally is going to be limited to a metal with a lower melting temperature, simpler parts and geometry compared to the sand casting because of the need to open the mold. Also, the high cost of the mold manufacturing. Die casting is a permanent mold casting process in which the molten metals is injected into a mold cavity under higher pressure. The mold in this casting operation are called the dies, and hence the name, the die casting. Its use of high pressure to force the metal into a die cavity is what distinguishes this from the other permanent mold processing. First type of the die casting process is called the die casting hot chamber machine. In this process, the metal is melted into a container attached to the machine. Then, a piston is going to be used to inject the liquid metal under the higher pressure into the die cavity. In the die casting cold chamber machine, the molten metal is poured into a chamber from an external melting container. The piston is going to be used then to inject the metal under the high pressure into the die cavity. The main advantage of the die casting process are, first, it's economical for the large production quantities. It has good accuracy and surface finish. Thin sections are possible, and rapid cooling means that the smaller grain size and good strength in the casting. Squeeze casting is a combination of casting and forging. The molten metal is poured into the preheated lower die, and then the upper die is closed to create the mold cavity after the solidification begins. The mold halves closed after the introduction of the molten metals. Less pressure and finer surface details can be achieved. The semi-solid metal casting. This casting process with the metal alloys at a temperature between liquidus and solidus. In this state, the alloy is a mixture of the solid and molten metals during the casting, or what known as the mesh state. We need to keep the metal at this state for a longer time. To flow probably, the mixture must be consist of solid and metal globs in the liquid. To achieve that, is the stirring of the mixture to prevent the nitrate formation. The mixture then is going to be applied to a piston that injected inside the mold. Leave it to solidify, cool down, and eject it. The centrifugal casting is an ideal process to make the seamless pipes and cylindrical shapes. The process is done by introducing the molten metal into a high-speed spinning mold. Sound metals will solidify into cylindrical shapes under the high pressure due to the centrifugal force. The centrifugal casting can be classified into three main groups: the true centrifugal casting, the semi-centrifugal casting, and the centrifuge casting. In the true centrifugal casting, The molten metal is poured into the rotating mold to produce a tubular parts such as pipes, tubes, and rings. The outside shape of the casting can be round, octagonal, hexagonal, or any other shape, but the inside shape is theoretically perfectly round due to the radially symmetrical force. The continuous solidification starting from the outside surface due to the chilling effect with the metal mold eliminates the shrinkage and inclusions from the casting. The centrifugal forces makes cylindrical shapes with accurate concentricity. No traction, no stress inducting factors during the solidification makes a residual stresses a minimum. Subsequent operation required to be done after the casting process, and the most advantage of this process is the elimination of the shrinkage, minimize of the residual stresses, and the accuracy in the dimension. In the semi-centrifugal casting, the centrifugal force is used to produce a solid castings rather than a tubular parts. The density of the metal in the final casting is greater in the outer sections than the center of the rotation. The process is used on a part in which the center of the casting is going to be machined away, such as the wheels and the pulleys. In the centrifuge cast, the mold is designed with the part cavities located away from the axis of rotation. The molten metal is poured into the mold, is distributed to these cavities by centrifugal forces. Usually it's used for smaller parts, and the radial symmetry of the part is not required as in the other centrifugal casting methods.